Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at how to calculate the equation of a parabola. So all parabolas have the general equation y equals ax squared plus bx plus c. So if we have a parabola like this and we wish to find its equation, all we need to do is find a, b and c. So for this first example, what we're going to do is look at the intercepts. So this is how you find the equation of a parabola when you're given its intercepts. So it has x-intercepts minus 1 and 4. So we're sort of reversing the null factor law. If negative 1 is an x-intercept, that means x plus 1 is a factor, because the opposite of the null factor law, negative 1 is the value for x that makes this first bracket equal 0. And similarly, if 4 is an x-intercept, then we must have x minus 4 as a factor, because if x equals 4, it will make this second bracket equal 0, and then y will equal 0. Remember, y equals 0 at each of these 2 points. So when you're finding the equation of a parabola with x-intercepts given, it's x minus first intercept times x minus second intercept. But there is a slight problem with that. The problem is that I could literally put any non-zero number here without changing its intercepts. In fact, you've probably noticed that because this is a frowny face, the value of a actually has to be negative. It's not going to be positive. So how do I actually find the number that goes there? Well, I'm just going to write it as a for now. What I'm going to do is substitute into this equation a point, but it has to be a point other than the x-intercepts. It's like we've got all the information we can already from these 2 points. We need another point other than the x-intercepts. So you can pick any other point that is clear, where you can clearly see its coordinates. So in this case, I'll pick this point here, the y-intercept, 0, 2. I'm going to substitute x for 0, y for 2 into this equation. So if I do that, I get 2 equals a. Now replacing x with 0, first bracket's 1, second one is negative 4. So I have 2 is equal to, now 1 times negative 4 is obviously negative 4. So 2 is negative 4a. Divide each side by negative 4, you get a equals negative a half. So the equation of this parabola is y equals negative a half x plus 1, which is x minus first intercept, times x minus second intercept. So if I'm asked to give it in this form, I need only now to expand this. So I'll leave the negative a half alone for now. So expanding this using FOIL is x squared minus 3x minus 4. And now I just multiply everything by negative a half. Negative a half x squared plus 3 over 2x. And negative a half times negative 4 is positive 2. So a is negative a half, b is 3 over 2, c is 2. All right, let's now look at finding the equation of a parabola when we're given 3 points. So when you are given 3 points like these and you need to find the equation of a parabola, you use simultaneous equations. See, once again, we know that the equation is going to be of the form y equals ax squared plus bx plus c. So I need to find simply the values of a, b, and c. But in this case, I actually know c. This is made a bit easy because I'm given c. It's here. C must be 6. 0, 6 means the y-intercept is 6. It means when x is 0 and these terms are 0, y equals 6. So I'm going to replace c now with 6. So how am I going to find a and b? Well, I'm going to use the other 2 points to set up simultaneous equations. So let's substitute in this point. I'm going to substitute x for negative 2 and y for 20. So I get y equals a times x, which is negative 2 squared, plus b times x plus c, which I figured out was 6. So just to make this a little easier to work with, I'm going to subtract 6 from both sides. So subtracting 6 there makes that 14, and subtracting 6 over here goes away. Now negative 2 squared is positive 4. So this becomes the equation 14 equals 4a minus 2b. That is my first equation, which I obtained from this point here. Now, to find the second equation, I'm going to use this point. I'm not going to use the 0, 6, because I already used that to find c. I'm going to use this point here. So we have y equals a times x squared plus b times x plus c. Once again, I'm going to subtract 6 from both sides to make this a little easier to work with. I just get -1 equals a plus b. So now I need to solve each of these equations simultaneously. So to use the elimination method, I need to make a or b have the same coefficient. I'm going to times this equation by 2. So I'm going to get -2 equals 2a plus 2b. So I now have two simultaneous equations. B has a 2 in front of it in both, so I'm going to add together these two equations. So I go 14 plus -2 is 12, 4a plus 2a is 6a, of course -2b plus 2b is 0. So 6a equals 12, a equals 2, and then from this equation, I have -1 equals 2 plus b, subtract 2, you get b equals -3. So the equation of this parabola must be y equals ax squared plus bx plus 6, and then I'm done. All right, now we're going to look at a harder version of this where you're not given c. So once again, we're going to find the equation of a parabola from 3 points, but this time we're not given c. So once again, the equation of any parabola is y equals ax squared plus bx plus c. I need to find a, b, and c, and I'm going to do that by using simultaneous equations. So I'm going to get 3 simultaneous equations to solve, one from each point. Let's substitute in this point to this equation. So y is -20, so I get y equals a times x squared. So x squared, -3 squared is 9, plus b times x, x is -3. So I get -3b plus c. So similarly for the next one, y equals ax squared plus bx plus c. And for the last one, y equals ax squared, x squared is 25, plus bx plus c. Okay, how am I going to solve these equations? Well, notice that these two equations help a lot because both a and c have the same coefficient in each. So if I subtract the second equation from the first, I will eliminate both a and c and I can find b straight away. So let's go and do that. So we get -20 subtract -8 gives us -12. Then we go 9a minus 9a is 0, -3b minus 3b is -6b, and then c minus c is 0. So straight away from that, I know that b is equal to 2. So what I'm going to do is substitute b equals 2 in each of these two equations. I can't use the first two together because I just used them to find that b is 2, so I need to substitute it somewhere else. So I'm going to replace here 3b, 3 times 2, with 6, and I'm going to replace here 5b with 5 times 2, which is 10. So just rearranging each of these equations, this one becomes, so I'm going to subtract 6 from both sides, -14 equals 9a plus c. And then the second one, I'm going to subtract 10 from both sides. It becomes -30 equals 25a plus c. So once again, I eliminate. I'm going to eliminate c by subtracting. -14 subtract -30 gives me +16. 9a minus 25a is -16a. So I get a is equal to -1, and we can see pretty clearly from this one that c must equal -5. So the equation will be y equals ax squared plus bx plus c, which was -5. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.